10.5. The student dissolves a few drops of propylamine in 1 centimetre cubed of water in a test tube. Give an equation for the reaction that occurs. Well, propylamine, amines are bases. It's got an NH2 on it. It's got 3 carbons, a propyl and an NH2. An NH2 group can accept H pluses, act as a base. So if it accepts H pluses from H2O, this is what happens. Propyl, CH3, CH2, CH2, NH2, and from the water it accepts an H plus because it's a base, an H plus acceptor. If it accepts an H plus from the H2O, the H2O has lost an H and it's become minus. Observation, if that's a base, then it's going to go blue, the indicator, so the indicator goes blue. Propylamine can be prepared from a process involving the reduction of nitrobenzene. So benzene, a benzene ring with an NO2 on it, using tin and an excess of hydrochloric acid. Another way of getting NO2 groups on a benzene to an NH2, phenylamine and amine, NH2, would be to add hydrogen and nickel. But in this case they want to add tin and hydrochloric acid. It's another way of doing it. Give an equation for the reduction. That means removing the O's off the NO2 group and making NH2s to form phenylamine. Use H square brackets to represent the reducing agent. The reducing agent is the tin and the hydrochloric acid that's removing the O's from the NO2 part of nitrobenzene to make NH2. Explain why an aqueous solution is obtained in this reduction even though phenylamine is insoluble in water. Okay, first of all let's do the equation. So you can either write that as C6H5NO2 or you can draw it out as a benzene ring with an NO2, whichever you prefer. Now when those become NH2s, the O's become waters, and I'll need 2 waters to balance the 2 O's. Therefore I'll need 1, 2, 3, 4, 5, 6 H's, and I'll represent that with 6. And the square brackets H means that's coming from the reducing agent from the tin and hydrochloric acid in some way. Explain why an aqueous solution is obtained in this reduction even though phenylamine is insoluble in water. That's tricky, that. This is a base. NH2 is still a base, and the base will react with hydrochloric acid. And if this NH2 reacts with hydrochloric acid, that will make NH3 plus, take the H plus from the hydrochloric acid, NH3 plus and Cl minus. So it's going to make NH3 plus Cl minus, which is ionic and will dissolve in water. Tricky part of the question, that.